Hello guys. We are going to look at the first part of the third question. Yes, we've been given this equation and then we are supposed to determine whether the differential equation is exact. Yes, so we are looking at exact equations. So we have the expression 4t cubed y minus 15t squared minus y dt plus t squared minus t plus 3y squared dy is equal to 0. Yes, so we are to prove that if this equation is exact or it is not. So without wasting much time, let's see how we go about this question. Okay, so we can express this question in simpler terms. Yes, so in doing that, we can say that the first part of the question we can represent that by m, and then the second part we can represent that too by n. So let's do that. So m, and then t, y. Yes, so that is the dimension. We have t and then y, so the dimension is 2d is equal to, yes, n plus ty. dy is equal to 0. Okay, yes, so that's how we can represent this. So we can see m is equal to 4t cubed y minus 15t squared and then minus y. Good. Our n also is t to the power 4 minus t plus 3y squared. Good. So from this that we have, we can say that an equation is exact if, so this is the condition for an equation to be exact. So we have del of m over del of y is equal to del of n over del of t. Yes, so this is the condition for an equation to be exact. So let's find these terms. So first we focus on del of m over del of y. So let's do that. We have del of m over del of y is equal to del of over del of y. So we put our m term there. It's supposed to be del of m. So m is 4t cubed y minus 15t squared minus y. Good. So we are differentiating this with respect to y, right? Differentiating with respect to y. Good. So at this point, we have to differentiate the terms, the m terms. Good. But note that if it is with respect to y, any term that does not have y goes to 0. So in this example, the 15t squared goes to 0. So let's focus on the first part of the equation. Let's differentiate the 4t cubed y. So this is going to give us, when we differentiate y, we get 1. So 4t cubed times 1, which is 1. 1 is an identity element. Normally we don't write it. So minus, when we differentiate the y there, we are going to get 1. That is differentiation. Yes. In case you are not well conversant with differentiation, let me just do some short demonstration here. Okay, but let's finish solving the n. So we have del of t. of t is equal to del of over del of t, and then so our n, we put in our n values there. N was t to the power 4, t to the power 4 minus t plus 3y squared, y squared. All right, so this is with respect to t. We are differentiating with respect to t. So this also means that every term in this equation that does not have t goes to 0. Yes, so when we look at this equation, we will see that the 3y squared does not have any t inside. So since it doesn't have any t inside, then it goes to 0. Let's write this in here. So we have del over del of t, and then our n term was t to the power 4 minus t plus 3y squared. So let's write that. T to the power 4 minus t plus 3y squared. So plus 3y squared. Good. So what I was saying was every term that does not have t goes to 0 because it is with respect to t. Now let's differentiate the t. When we differentiate the t, we get 4t cubed minus t. When we differentiate that, we get 1. Yes, so let me make things clear here. When we differentiate this t to the power 4, the 4 will drop and then we subtract 1 from the power, so it becomes 4t cubed. So that is how we had the 4t cubed at that side of the equation. Yes, so this 4t cubed minus 1 becomes del of n over del of t. So now we've had the values for del of n over del of t, and then del of m over del of y. So comparing the two equations, we go see that they all have 4t cubed minus 1. Yes, the n has 4t cubed minus 1, and the m also have 4t cubed minus 1. So we can say that del of m over del of y is equal to del, that's 4t cubed minus 1, and then del of n over del of t is also equal to 4t cubed minus 1. Good. So from here we can see that the equations are equal, right? So del of m over del of y is equal to del of n over del of t. Yes, let's correct this part. It's supposed to be del of m over del of y. This was with respect to y, so let's correct that. Y. Okay, yes, so at this point we could see that the equation is exact. Yes, so we've checked for the exactness of the equation, and then we realized that they all have the same value. Yes, so let's say if we put t equals to 1 into both equations, we are going to get 4 minus 1, which is 3. So the equation is exact. So this is our conclusion. We've concluded that the equation is exact. Good. So if you have any question, you can drop that down in the comment section. If you have anything you want us to help you with, don't hesitate, right? And don't forget to like this video and then click that subscribe button that you stay updated whenever we upload a new video. Thank you.